Hello, everyone. My name is Jackie Porter. I'm the project manager at Arizona State University. I'd like to welcome you to this session. And with that, I will hand it over to Michael. Michael?
Hello, everyone, and welcome to the ASU Winter Games 2021 session on Cbrs, otherwise known as the Citizens Broadband Radio Service. My name is Michael Socha. I'm the Senior Business Development Manager for Cox Business Smart Communities based out of Atlanta. On our panel today, we've got three distinguished guests who will be talking about Cbrs and their extensive experience in that realm. First introduction is Brett Lasher. He's an innovation leader who heads the mobile private network strategy for Cox Communications New Growth and Development Group. He's responsible for ideating around new commercial opportunities, leveraging the Cbrs spectrum, as well as testing and piloting private network opportunities across various use cases and verticals. Prior to his work with New Growth, Brent spent time at Cox in the corporate strategy and mergers and acquisitions area. Brett holds a BS in finance from the Wharton School at the University of Pennsylvania and an MBA from Duke University. Please welcome Brett Lasher. Virtual clap, everyone. Our next guest is Somi Alapati. He's a Principal Solutions Manager at Ericsson based in Plano, Texas. He is responsible for strategy and wireless solutions for Ericsson's cable carriers in the United States. With over 24 years of experience in wireless and communication systems, Somi has held a variety of technical and leadership roles, including product architecture, product management, engineering, research and development, and technology trials for Ericsson Nortel networks. Somi holds a master's degree in computer science from the University of North Texas in Denton, and has a bachelor's degree in computer science and engineering from the National Institute of Technology in Warangal, India. Please welcome Somi Alapati. Virtual clap, thank you very much. Next is Paul Blazer. Paul Blazer is a director of wireless technology at Cox and leads our engineering activities for wireless centered around MVNO, private managed networks, and fixed wireless access. Paul spent the last 10 years leading outdoor and indoor small cell engineering and deployment organizations for Crown Castle and AT&T. Previous to that, Paul spent over 20 years in various wireline and wireless engineering roles for wireless carriers, telco, and engineering service organizations. Please welcome Paul Blazer. Thank you, Ann. All right, to keep up with the Winter Games theme, a previously exclusive ski run has opened up, clearing the way for the Internet of Things. To expand innovation and technology, the newly available Citizens Band Radio, or Cbrs, licenses are enabling exciting new possibilities for emerging technologies, community connectedness, and innovation. But first of all, let's talk to the panel and talk about exactly what is Cbrs and give us a little background on it. Brett?
Thanks, Michael, and excited to be here today to talk to this group. So as you mentioned, Cbrs is spectrum that has recently become available to commercial users. It is theoretically known as mid-band spectrum. So it basically falls within kind of the 3.5 and 3.7 gigahertz on kind of the spectrum band. It's referred to as affectionately as kind of the Goldilocks of spectrum, in the sense that it is kind of just right with regards to coverage and capacity. So it is high band enough. As you get higher up the bands, you get greater capacity, and so it has meaningful capacity, but it also is kind of low enough on the band where you have great coverage as well. So it's a very useful part of the spectrum band. Historically, it's been used by ground satellite providers as well as the US Navy. Although the FCC has been making waves and kind of clearing off that spectrum for commercial use over the past few years. In fact, this project was kind of first identified 10 years ago when the FCC's 2010 broadband plan is they're looking at ways to clear additional spectrum for innovation. And kind of it all came to fruition in January of last year, in January of 2020, when the FCC finally approved the commercial use of Cbrs spectrum, which opened up a whole, as we call, new run for innovation. And I think, if I point to the two things that are most exciting or unique about this spectrum, that's maybe a little different than what's out there today. So first and foremost, it is LTE compatible. And so it's really good for mobility use cases, unlike Wi-Fi. And so as you think about all sorts of new mobility use cases that are coming to fruition, whether that's connected cars or robotics or the like, it is a great spectrum that's applicable to kind of those use cases. And then the most unique thing about it, it's kind of the first, what we call kind of lightly licensed or co-licensed spectrum that's out there. So if you think about the Cbrs band being 150 megahertz in width or in size, about half of that, or 70 megahertz, is privately licensed or sold off through kind of private access licenses or PALs. And those are sold by the county level. But then 80 megahertz, or a little more than half of the spectrum, was allocated for general use, or they're called GAA, or generally authorized access. And so basically that means that spectrum is allocated on a first come, first serve basis. And so it's kind of the first spectrum that folks can use for private networks that is, in many ways unlicensed or lightly licensed. So pretty unique, and we'll get into it a little bit later, but opens up a whole new way of kind of leveraging spectrum for commercial use.
Excellent. Thank you, Brett. So next we want to talk about some of the use cases that are out there. How is it applied to different verticals, different markets, different industries that are out there? So I'll kind of toss up to Somi and talk about some of the use cases that he's seen through Ericsson.
Yeah. So there are a couple of things that are happening in the industry. So you have the whole modernization happening with Industry 4.0, where flexibility, safety, automation, mobility are becoming very important to these industries. And then on top of it, pretty much you have all these video-centric applications, video analytics, AR, VR, those kind of applications are also driving those industries. Then you see Cbrs spectrum. It's a very good spectrum, like Brett is talking about. It's the Goldilocks of spectrum, where you can get better coverage, better mobility, better latency. And with this, it brings in a lot of these use cases where private LTE networks can serve those use cases. Things like, if you look at supply chain and logistics, so you can do monitoring, tracking, hazard and maintenance sensing. I mean, those kind of applications can be supported. And then if you look at the operations and productions aspect, then you can look at enhanced video services, HD video, AR, VR, then augmented reality. It's part of the product innovation capabilities in these manufacturing industries as well. And then you have the connected vehicles or autonomous vehicles. You could also have remote operations and real-time automation of your application. So with this, we have been working a lot of use cases in the automotive, manufacturing, ports, airports, public safety, oil and gas, energy and utilities, media and entertainment, those type of industries. So all these industries have some use case where I talk about the type of things that you could do with a LTE network.
Excellent. Thank you, Somi. Brett, do you have anything to add to that?
Yeah, and we can get into different levels of detail, but I think a couple of things that are probably pretty interesting and relevant given what's going on. Somi talked about some of the specific use cases and industries. I think, generally we're seeing some interesting use cases and what we call kind of fixed wireless access. And so an example there has been spurred by the pandemic. And so you have students who are now learning from home and using Zoom or video calls all day. And you have a variety of students and different kind of socioeconomic backgrounds. And so you have a number of school districts or students within those school districts who don't have access to Wi-Fi. They were dependent on their school for internet access. And so there's been a number of interesting projects that have been stood up where you've been able to provide kind of a broad canopy of connectivity throughout a neighborhood or a school district that now provides connectivity for these students to enable that learning for them that was not possible before. So it's been a really interesting use case that has accelerated the use of CBRS over the pandemic. And then the other piece, which is kind of more broad, and we get into it perhaps later on, but we talk about enterprise private networks. And so historically, enterprises either used Wi-Fi, which is kind of unlicensed and can be congested, or they try to leverage cellular connectivity from some of the major providers like AT&T or Verizon. With CBRS, you can actually have kind of your own private wireless network with reliability. So it provides all sorts of interesting wireless use cases that were never feasible really before. And so a perfect interesting example, which I like, is a casino up in Washington stood up a private wireless network across the entire casino. And one of the issues that they had was, to site gaming machines, it was just really difficult and expensive because you had to have a wired connection into every gaming machine. So if you ever wanted to renovate your casino floor or move gaming machines around, it was a huge, effort and expense to do so. And so now with this kind of this mobile private network, they can use wireless connectivity, have their own private network within the casino, and basically place machines anywhere that they would like, or where there is power. So just some really interesting, unique use cases that have been unlocked, and happy to kind of talk in more detail as we get through the presentation.
Okay, sounds good. So Paul, I've got a question for you. So why is CBRS so important for the next generation of IoT?
Yeah, so the CBRS spectrum really allows a tailored usage for IoT. And IoT, I know Brett and Somi just talked about use cases, and that's anything that's not a handset, right? So it's machine to machine. But I think it was hit on a couple of times, but at the 3.5 gigahertz band, it's a really good balance of signal propagation, so it travels well. It has in-building penetration, and it has both priority and general access available bandwidth. So the infrastructure and the diversity of users allows for the potential of lower cost and higher volume LTE devices, which is really key to do a rapid deployment for IoT. And then I think most importantly, it's making the business case work, because it's all about device costs. You got to have a volume of devices and low cost. And from a 5G new radio advancement of CBRS devices, that's really going to be rolling out later this year. So this will help future-proof IoT deployments with ecosystem availability, and it's going to allow for the benefits of 5G, including increased number of devices on a network, lower latency, enhanced data rates, and network slicing benefits to the end customer for ease of network deployment. So that's really what I had on this topic.
And so, Somi, how is this deployed? How is it different than what's currently available?
So if you look at a LTE network, right? So all it consists of is a base station, which will be a cellular base station transmitting LTE on 3 or 5 gigahertz spectrum. And then you have a core network. And the core network, the base station has to be present right on the site. It will be like a Wi-Fi node, or you need to have some type of coverage at that particular use case location. And it is providing you the cellular coverage. And then you have a core network, which could be on site. I mean, depending on the type of latency that you need, how critical that latency factor is. So you could have these ultra reliable, ultra low latency type of applications. So for that, you need to have a core network on the site, which provides you the internet point of presence. Or if you don't think that these are important, wherein you can tolerate a little higher latency, then you could have your internet proper presence locations at a different point in the network, somewhere in a centralized location. So that's pretty much it. So you have a radio access network and you have a core network. And all the scheduling, all of that is done through the radio access network and the core network. And you get your IoT or fixed wireless access applications, or even mobility type of applications. So even the major operators will be using Cbrs for their mobility offload, right? So, and in those scenarios, yeah, they are definitely deploying radios on towers, radios on utility poles. But if we talk about indoor type of use cases for these IoT applications that we talk about, then you need to have indoor base stations or indoor small cells. So that's the overall architecture.
So it can be deployed either indoors or outdoors, correct?
Yes.
And then what's the level of bandwidth that's available between that spectrum?
So there is a total of 150 megahertz of spectrum. And if you look at the throughputs that are possible, so in each 20 megahertz channel, the peak speeds roughly could be around 120 to 130 Mbps. So you can do the math, and so, but usually all the devices, so you have to look at the category of devices. So all the devices don't support more than a couple of channels, like 5 or 6 type of 20 megahertz channels. So you can get up to gigabit throughput if you put all these channels in a carrier aggregation mode from a peak capacity perspective.
So it can handle the bandwidth of any sensor that may have low bandwidth usage and some that may have higher bandwidth usage, correct?
Yeah. So I want to clarify that statement. So the throughput that I was mentioning, that is the throughput on the downlink. On the uplink, LTE, so in a 20 meg channel with just 2 by 2 MIMO, which means 2 streams of information being sent out. So you can get up to 20 megabits per second. And you multiply that with maybe 2 carriers or 3 carriers from a carrier aggregation perspective. So that will be the total limit that you will have. So your IoT devices, if it is very low data requirement, so it should be fine. But your cameras, for example, can consume anywhere from maybe 1 Mbps all the way to 10 Mbps. So in that scenario, you have to pick and choose your network design in such a way that you place the right number of devices for you to be able to get that through.
And Paul, can you talk about some of the advantages of what a CBRS network can bring to an organization or to a city?
Yeah, sure. First and foremost is the spectrum is spread across a diverse set of owners. So there's both large and small operators, there's energy companies, utilities, and enterprises alike. So there is, general available access to the spectrum, which allows significant innovation to be done outside of the PAL licenses that Brett was talking about, which were auctioned off this summer. So that increases really the number of potential users and the various use cases already discussed. So it allows for a lot of devices. So there is also full access to low-cost devices because of the popularity of the band through the efforts of the CBRS Alliance and its OnGo device certification process. So OnGo will certify every device. It's got thousands of devices already approved, and this makes for a very low cost deployment. from a device perspective. The spectrum sharing entities or spectrum access system operators have also shown that this model of dynamic network sharing is working well in protecting the original incumbents with the new licensed usage. And it allows for the maximum use of the band for the various use cases. As I've said before, also the 3.5 gigahertz band, it just does such a good balance of signal propagation, in-building penetration, because you get into the higher frequencies, they just don't penetrate buildings. So this platform or this spectrum is just a great balance. And then again, having that 150 megahertz of spectrum available. So currently Cbrs supports LTE, but with 5G new radio devices rolling out in the latter part of 21, this is going to help, drive lower latency, support more simultaneous users, have faster throughputs. And it's a combination of all these things that really show the advantages of a Cbrs network.
Excellent. Thank you, Paul. So Brett, is this spectrum that was previously used for military applications, is it just for carriers, or is it going to have a wider application for enterprise now?
Yeah, as Paul kind of touched on, it's basically for everybody. And so, not only did enterprises buy priority licenses, but also, like Paul mentioned, utilities were very active in purchasing licenses, as well as enterprises like John Deere. But outside of owned licenses, more than half of the spectrum is allocated for general access. So anybody can basically stand up a network, have an arrangement, or sign up an arrangement with one of the SaaS providers and stand up their own network. So you're going to see businesses of all sizes, office buildings, retail providers, all providers start to stand up these types of networks. They're going to be much more prevalent, I think, throughout cities and rural areas. I think, Paul touched on it. I think one of the things that for folks who may not be as familiar with how this network works, but when you think about, how people are granted access to this network, you have these SaaS providers who basically are the air traffic controllers of the spectrum today. And so basically, if you are a person who is not an incumbent, so not part of the military or don't own private licenses, you basically ping this air traffic controller who will look at the network and see if it's being used by the incumbents first. And then it will see if any of the private or the priority access licenses are being used. And then to see what kind of capacity is on the GAX spectrum. And then we'll kind of grant access to the spectrum based on what is being used. So it's kind of a first come, first served type model. And then on top of that, even though folks own priority access licenses, when those are not being used, those bands are actually, or those part of the spectrum channels are able to be used by the general public as well. So it just opens up a broad swath of spectrum for general usage that is very reliable and very secure.
Thank you, Brett. So let's talk about like the use cases in education. The rural capabilities or the rural access that everyone's talking about, and the equal access or equal access to the internet for schools that may be in further out than some of the cities.
Yeah, I can touch on that. So we talked a little bit about some of the maybe perhaps underprivileged areas that aren't able to afford access. There's a couple other similar use cases where this has been interesting. So there's parts of communities that where it just doesn't make sense for telco or cable providers necessarily to build networks, whether it's because they're too far out or it's just there's a large difficulty in construction. So we're looking at use cases now, like in mobile home communities or tribal communities where they previously have not had any network built to those neighborhoods, where we can now leverage this wireless technology and provide connectivity to folks who previously have not had any access, and provide them internet access for educational purposes. Similarly, we talk about rural access, and because of some of the coverage characteristics of this spectrum, where it can be propagated over long distances, it can similarly be propagated to kind of rural areas. And so one of the federal government's current pushes is to expand internet access to rural areas, and people are looking towards Cbrs to help provide some of that access or fill some of that gap. And in part it will be used for educational purposes for rural students.
So what kind of distances can you get out of a network? And
yeah, so in a fixed wireless access network, I'll take that question.
Yep.
So in a we have had several fixed wireless access deployments, and we are seeing a range of at least 10 miles of coverage in rural environments. And we see somewhere in the 5-mile type of coverage in a semi-rural type of environments. So, we are able to get at least a speed of 100 Mbps type of service. So 2 or 3 20-minute channels. With line of sight.
Just to put a finer point on Somi's comment, I think it depends on where the area is located and kind of what line of sight you have or do not have, and what kind of geography is impeding the radio in between the radio and the end user. But yes, and as you talked about, and outside of Ericsson, we've seen other trials by providers in rural areas where they're seeing even more than 10 miles in areas where there's not many geographic impediments between the radio and the end user. So it's much better than Wi-Fi in that regard.
Yeah, good point, Brett. So yeah, it definitely depends on the terrain, and yeah, if there is a lot of foliage, so then you have to worry about that. And but yeah, usually in a very rural line of sight, that's where we get the 10 mile or even more. We have seen better results, but it can vary anywhere from 4 miles to 10 miles depending on the terrain conditions.
All right, well, we've got about 15 minutes left, so we want to be able to open it up for questions for those in attendance. And Jackie, are there any questions in the chat box?
There is a question, but there's a comment from Mark Goldstein about delivering. He delivered a deep dive next generation wireless overview and presentation to the IEEE Computer Society of Phoenix, exploring the underlying emergency technologies, protocols and standards, market trends and opportunities, covering all today's wireless advances as well as operational and policy challenges. So he offered the deck for people to look at as well. And then he has a question. It says, concerned with some near coastal U.S. projects and limitations on available bandwidth where active sensor networks for military and other priority use are not yet in place. How do you see this evolving?
Yeah, so I think, so as you guys know, right, so the radar, military radar uses the spectrum today. And so in these coastal areas, in Norfolk, example, right? So that's one example. Philadelphia is another example. So in those locations, if that spectrum, if the aircraft carrier comes in and it wants to use the radar, you need to they use the 3.5 spectrum to be able to help them land on the aircraft carrier, right? So that's the use case that they have. So when those aircraft carriers come through, then they have to use that spectrum. And in that scenario, what will happen is the spectrum that is being used by, let's say, some application or some operator. So that's the SAS then informs the operator saying you have to relinquish that spectrum. And if there is any other channel that is available, then it can use the other channel. But there is a specific range of frequencies that the radar uses. So And what happens is then it goes into this DPA, it's a domain protection type of condition. And so you wouldn't be able to use that spectrum when those aircraft carriers come in. So that's the challenge today. And as the algorithms become better, as the radar, I think those folks decide on using specific channels, maybe that can get a little better.
Yeah, maybe just to add to that, I think the SaaS providers have done, especially a couple of them, they built out these ESC networks around these radar installations. So they can sense when the radar hits, and it's millisecond dynamically allocated. So that's how quick these channels change. This is very new. It's a very new approach to spectrum usage. Typically, spectrum has been, the incumbents have been moved out of the space. This is really one of the first times that the incumbents still are in the space and this SaaS operates. So there's an external network that they built that helps operate this. So, and I think it's taken some tweaking, but we're seeing positive results as these SaaS operators have deployed these sensing networks.
Yeah, and just to put a final point on it, I mean, I've seen a map by some of the network providers to kind of diagram where they think there will be interference. And in terms of the number of areas, it is really, really small number of areas where they think there'll be interference. It is, as we talked about, mainly around some coastal areas, and then there are a few kind of land bases where there may be some radar interference, but it is a really, really small set of areas where they're expecting interference to be from incumbents.
All right, we have one more question from Stephen Craig Burrell. Speaking of SaaS providers, are there attributes about authorized providers that should be considered? And he has provided a link, but
I did not understand the question. Can you repeat it, please?
Speaking of SaaS providers, are there attributes about authorized providers that should be considered?
Yeah, if this is around the SaaS providers, they, as Brett had said earlier, the Cbrs spectrum has been under discussion for upwards of 10 years. And the SaaS providers, there's really 5 of them, 5 big ones today. They've been engaged in this process over that 10-year period of time. There's a few that are leaders and have most of the customers, the current radios. So they put a heartbeat out to each of the radios that operate. It's not the end users, it's actual radios. And so they've worked through with the FCC how they will operate. They coordinate closely with each other's networks. So they're all tied together and interoperate. And one SaaS provider knows what the other SaaS provider's customers are doing, as well as where their ESC networks are. So it's a well orchestrated process as part of Cbrs.
Yeah, the other thing I'm hearing from that question, and Paul and Somi, you may have a better answer than I do, but is, if there's 4 or 5 SaaS providers out there, how do you distinguish between them, or what attributes or characteristics do you use to evaluate one versus the other?
Yeah, and so I think kind of the keys to what a SaaS provider has is they have to calculate interference from where. So 2 things, they protect the incumbent. So in protecting the incumbents, they have sensing, these ESC sensing locations near radar installations and other incumbencies. And so a good one will have a network built out. They'll have had it certified by the FCC because there's a certification process. And then outside of protecting the incumbents, there's coordinating for the SaaS customers, which is all of these folks that either own spectrum or the general authorization. So if you want to go use the general authorization, you have to go to a SaaS provider. And and work an agreement basically with them to light up a radio. And so with that process, they have basically a propagation tool that not only records where every one of these CBRS radios is located, but what interference may be occurring. And it's basically real time. They do adjustments of channels. So it's a prop tool, interference analysis tool, and then the ESC network. Those are, and how well they've done with certifications with the FCC that would kind of give you insights as to who's leading the space from a SaaS provider.
Yeah, absolutely, Paul. So yeah, those SaaS vendors, they need to talk to each other in a particular area for them to be really coordinated. And what we are hearing is that that particular item is on the roadmap. It's not there yet, but at some point you will have the SaaS, each SaaS talking to another SaaS so that they make these channel allocations completely independent, so that completely synchronized, wherein they don't allocate the same channel if they're talking to similar, if they are talking to two devices in the same area, two radios in the same area.
All right, looks like we have time for just a couple more questions, Jackie.
Here, one more question. It says here, it sounds like a great option for new entries into the wireless service space. Who do you see has the best opportunity to use CBRS to either augment existing or build new either augment existing or build new service offerings?
I can take a stab at it. The first use case that the mobile operators are doing is just deploying CBRS base stations for additional capacity. So that's the mobility portion, right? So wherein they are augmenting the capacity of their existing networks with CBRS. The second use case that we talked about was fixed wireless access. This is getting a lot of traction in the rural industry. So there are a lot of rural operators who are benefiting with CBRS spectrum. Not a lot of them bought any priority access spectrum, priority PAL spectrum, the 70 megahertz that has talked about. So everyone is depending on GAA spectrum in those areas. Then you have all the private LTE use cases. And in these private LTE use cases, I mean, you could have anywhere from ports, airports, utilities, gas and electric companies. You could have any type of manufacturing facilities with those IoT type of applications. So all those guys are using, planning to use CBRS spectrum. We even have one use case in the Dallas area where they are planning to use CBRS for coverage on the dark train that we have here. So plenty of use cases and there could be other use cases in terms of neutral host type of use cases, wherein you could build your own network and then you could have a Verizon or an AT&T customer roaming onto your neutral host network. So I think the opportunities are many. It's how you are able to get good economic ecosystem and good overall network so that you can serve these different use cases.
And I'll put my spin on that. I mean, I think it's going to depend very much depending on how much hand-holding you need, what your use case is, and then kind of the economics of it as well. So, folks who have strong IT capabilities and don't need a complex network, I mean, they're coming out with CBRS networks in a box right now. I mean, AWS and Athonet have the kind of an in a box, out of a box solution. I know Ericsson may have something moving kind of in that direction. And so some people can kind of do this on their own, just meet up with an equipment provider and launch something. On the other hand, you have folks who either have more complex networks or just aren't familiar with networks, and you're going to need more handholding. And so you'll probably have service providers like an MSO like Cox, or an MNO like one of the existing telcos, who can provide kind of an end-to-end managed service. And then I think the other kind of axis is, are the services or the use cases mission critical versus not? And so if they're mission critical, you may kind of gravitate towards folks who have PAL licenses and guaranteed access to spectrum in your given geography. If it's maybe not mission critical, perhaps GAA or general access best efforts spectrum is good enough, and perhaps you gravitate towards folks who don't have access or don't need PAL licenses. And then the last piece is that, like most or all wireless networks, at the end of the day, it all needs to come back to a wired network. And so the provider either is going to have to own a wired network or lease a wired network from someone else. And so, wired network providers may have an advantage from a kind of cost and service delivery and perspective down the road. We'll kind of see how the market develops in that regard.
Excellent. Well, thank you to the panel for joining us today on this interesting discussion on CBRS. I hope that everyone learned a little bit more about how the network is and how it's deployed and some of the use cases that are available for this new spectrum. We certainly appreciate your time today, and we look forward to that next exciting journey into IoT and the next generation of technology. Just a couple of reminders for the folks in attendance. We've got lunch that is coming up, and there is a seminar on Productively Yours, Hackathon Outputs and Champion. At 4 o'clock would be Arizona time. We've got Reflections from the Top. And then at 5 p.m., Carrying on the Torch and the Medal Ceremony. So thank you all who joined today. Certainly appreciate your time and joining us.